Okay, the second part of 5.7, we are still talking about Pythagorean's theorem, but now we're going to do the second part, which is we're not going to find segment lengths. We're going to use Pythagorean's theorem to classify triangles. So remember, we can have a right triangle where there's one right angle. We can have an obtuse triangle which has one obtuse angle, or we can have an acute triangle where all three angles are acute. So we're going to use Pythagorean's theorem to tell whether a triangle is right, obtuse, or acute. And the easy way to do this is to think about what we already know. Well, we know if it's a right triangle, that means that a squared plus b squared equals c squared. Now, let's say a is 3 and b is 4. Well, we know that c has to be 5, right? Because it's a Pythagorean triple, which we just talked about. Let's say I still have side lengths 3 of 4. Okay. Let's say, however, I'm gonna make the angle between them a lot bigger. So this is still 3, just like this one's 3. This is still 4. It's a little bit longer, but there we go. This is still 4, just like this one's 4. And now we have a bigger angle. If this was 90 degrees and this is a bigger angle, this is going to have to be an obtuse angle, right? And what's going to happen, is that this C, do you think it's going to be 5 like it is over here in this triangle, or do you think it's going to be bigger than 5? Well, it looks longer than 5. So what that means is if we do a squared plus b squared, the c squared is going to be bigger than a squared plus b squared. We already know that 3 squared plus 4 squared is going to equal 5 squared. This is going to be bigger than 5. So if c squared is bigger, it's going to be an obtuse triangle. Similarly, instead of making it an obtuse angle, let's say we take the 3 and the 4. So this is 3 just like in the other two triangles, and this one's 4. And this time we're going to put them really close together, and this is an acute angle. It's smaller than the 90-degree angle and the obtuse angle. Now, if we did Pythagorean's theorem with this, do you think it's going to be bigger than 5 or shorter than 5? Well, this one is bigger than 5. This one looks way shorter than 5. So if we did a squared plus b squared, it's going to be bigger. So c squared is going to be shorter than a squared plus b squared. Okay? Because this one is going to be less than 5. It would probably be, I don't know, it would probably be like 4 or 3, somewhere between 3 or 4. This one could be like 6. Okay, so c squared is going to be bigger for an obtuse triangle. C squared is going to be smaller than a squared plus b squared if it's an acute triangle. Okay, so that's how we can tell what type of triangle it is. Now, before we even get to do that, let's think about the straws. Let's think about the triangle inequality theorem. Remember, if we have 2 side lengths and we were making 3 side lengths, let's say we were cutting straws and we're trying to make triangles, let's say one's 3 and one's 3 and one's 6. Remember, like I tried to do with my first geometry class ever? Could we make triangles out of those? No, because the 2 smaller sides have to add up to be bigger than the third side. So this would not make a triangle. So what we're going to do today is I'm going to give you 3 side lengths to a triangle, maybe, and you're going to first say, is it a triangle? So if you take the 2 smaller sides, 5 plus 7, is that greater than 10? Yes. So we know we have a triangle. Now that we have a triangle, we have to decide whether it's a right, obtuse, or acute triangle. So what we're going to do, the C is always the larger side, so we're going to say that this is C, and we can just say that this is A or B. It's really kind of arbitrary. And we're going to figure out what is it a squared plus b squared equals c squared? I'm putting a question mark because I'm not 100% sure. Well, we said c was 10, we said a squared was 5, and we said b was going to be 7. So 5 squared is 25, 7 squared is 49. If we add that up, is it going to equal 100? Well, we have 100 is not equal to 25 plus 49, 74. So C is bigger. C c squared is bigger than a squared plus b squared. When c squared is bigger, it's going to be an obtuse triangle. So that's how you know it's obtuse. So to do the same thing for the other ones. So 3.8, we can say that's A, this one's B, and this one's C. The first thing you're going to do is decide if it's a triangle. So 3.8 plus 4.1.
Mr. Hooper, please call Lucy at extension 0.
Is it going to
Mr.
be
Hooper,
bigger
please call Lucy at extension 0.
than 5.2? Yes, so we know it is a triangle, and now we need to decide what type of triangle it is. So we're going to say 5.2 squared, is it equal to 3.8 squared plus 4.1 squared? Okay, 5.2 squared, oops, is 27.04. 3.8 squared, 14.44. 4.1 squared, 16.81. And when you add those up, you're going to get that 27.04 is less than 31.25. And now this is the c squared, right? So when we have c squared is less than the a squared plus b squared, that's going to make an acute triangle. So this one is an example of an acute triangle. Okay, last one we're going to do, and then you can do number 5 by yourself. I'll check it tomorrow in class. Number 2, first, is it a triangle? If you add these up, 7 plus 12, is it going to make a triangle? Is it greater than 16? Yes, it is. And then you're going to do c squared, is it equal to a squared plus b squared? So c squared would be 16, a squared could be 7, and b squared could be 12. 16 squared is 256. 7 squared is 49, and 12 squared is 144. 144 plus 49 is 193. So 256 is greater than 193. So when c squared is greater, that means it's going to be obtuse. All right, so try number 5. And then I want you to answer reflection number 1. How can you use side lengths to classify triangles by its angles? And then I want you to practice simplifying the radicals. That's something that we haven't done a lot with this year. You should know how to do 1, 2, and 3 based on the last video. But for 4, 5, and 6, what you can do is, we don't like to have radicals on the bottom. This is going to help us out for the next section. So when you have radicals in the denominator, what you do is you multiply the top and the bottom by the radical, because radical 2 times radical 2, well, that's radical 4. And what's the square root of 4? 2. What do you think radical 3 times radical 3 is? Well, 3 times 3 is 9. And what's the square root of 9? 3. So the shortcut is that when you multiply a radical by the same thing, it's just going to be that number inside. So your denominator is now 2, and we don't have a radical in the bottom, which is good. But on top, we still have 6 times a radical 2. These two numbers are not the same. You can't combine them and say it's radical 12. You just have to push them together. But then if you look at the whole numbers, what is 6 divided by 2? That is 3. So your answer will be 3 radical 2. So let's do that one more time. Try number 5. And then number 6, I will help you out with. Number 6, when you have a fraction, what you do is you split it up so that the top and the bottom are both radicals. And then we have a radical in the denominator, which we don't like. So what we're going to do is we're going to multiply the top and the bottom by the denominator. And radical 5 times radical 5 is just going to be a regular 5. And now these are both radicals. So when they're the same, you can actually multiply them, and it's going to be radical 15. So I'm going to talk and answer this question. How are number 4 and number 6 similar? How are they different? And I will check that tomorrow.